So today we need to add all the notation notes to these, okay? Yesterday you should have written down a table that looks kind of like this. This is like your key. This is where you go to figure out what type of symbols you need and why. The inequalities we're going to use for inequality notation. The brackets and the parentheses we're going to use for interval notation. And then for set notation, we're going to use this symbolism that we came up with yesterday. The set of all x's such that x is an element of the real number system, and so on. Okay, so knowing that, we're just going to change our words into those symbols. So when we come to this first graph, we're going to do the inequality notation first. You should remember this from Algebra 1. In inequality notation, we're going to talk about all of the x's, and there's too many to list, but we know that they all fall in between. The smallest x value was -5. The highest x value was +5. Now, -5 on the x comes from a whole, so it's going to stay like this inequality. The +5 also came from a whole, so it's also going to stay that inequality. The interval notation, you're going to take those in, so -5 is the smallest, +5 was the largest, and you're going to write them like that. But then you need to figure out if you need parentheses or brackets. Because you had a whole at -5, it's a parentheses. Because you had a whole at +5, it's also a parentheses. Now the set notation is going to start with this sentence stem and then put your inequality in it. So we've got the set of all x's such that x is an element of the real number system and -5 is less than all of your x's and all of your x's are less than +5, and then close the set. So same thing for the range. For inequality notation, we have a lot of y values stuck in between 1 and 7. 1 came from a whole and 7 came from a whole, so we're going to leave the inequalities like that. The interval notation, we go smallest to largest. Because they were both wholes, we're going to use parentheses. The set notation is the set of all y's this time because it's range, such that the y values are an element of the real number system, and 1 is less than all of your y's, which is less than 7. Graph number 2. Graph number 2 for the inequality notation, we have a lot of x values stuck in between. The smallest x value we have is -5. The largest x value we have is infinity. Because the -5 came from a normal looking point, we're going to include it in our answer, but infinity is never included. When we take that to interval notation, it goes from -5 to infinity. -5 we are including, so it gets a bracket. Infinity is not, so it's a parentheses. Now, if we go back to inequality notation, we can write it that way, or a lot of times on a test, you'll see it written without the infinity symbol, so they'll just take and describe all the x's compared to -5. Well, all of your x values compared to -5 go this direction, and those numbers are getting bigger, so we can say it's greater than or equal to -5. The set notation is the set of all x's, such that x is an element of the real number system, and all of the x's are greater than or equal to -5. For the range, we've got a bunch of y values stuck in between. The smallest y value is -5. It's a normal point, so we include it. The highest is infinity, and it's never included. Or I can say that all of the y values in my graph compared to -5 are up this way. They get greater than or equal to the -5. In interval notation, we go -5 to infinity. -5 is included because it's a normal point. Infinity is never. The set notation, we have the set of all y values such that y is an element of the real number system, and all of the y values we're talking about are greater than or equal to -5. Okay, number 3. Number 3. Number 3, for our inequalities, we have a bunch of x values stuck in between. Our lowest x value is infinity, but because it's going in this direction, we have to state that it's a negative infinity direction. Our highest x is 6, or we can say that all of the x's are less than 6. For interval notation, we're going from negative infinity to 6. You never include negative infinity. At 6, we have a whole, so it's not included. We have the set of all x's such that x is an element of the real number system and all of the x's are less than 6. For the range, we have a lot of y values stuck in between. The lowest my graph goes is negative infinity. The highest it goes is 2. And we're not including either of those. The y values are all less than 2. The interval notation, we go from negative infinity to 2. Neither are included. Set notation, we have the set of all y's such that all the y's are an element of the real number system and all of your y's are less than 2. Okay, number 4. My inequality notation for the domain, I have a lot of x's and they're stuck between negative 5 and 2. Negative 5 came from a hole and 2 came from a hole, so we're going to leave them like that. The interval notation is from negative 5 to 2 because they're both holes, they both get parentheses. We have the set of all x's such that your x's are elements of the real number system, and negative 5 is less than your x's, which are all less than 2. The range, we said yesterday that it goes from negative 7 to 3. Now, the negative 7 this time is included because it comes from a normal point on the graph. This is a normal point. The 3 is not because it comes from a hole. So the interval notation is from negative 7 to 3. The negative 7 is included, so a bracket. The 3 is not, so a parentheses. Your set notation is all y values such that all of your y's are elements of the real number system and negative 7 is less than or equal to your y's, which are less than 3. All right, now, in class today, we stopped there. We skipped to question number 8. And this one's different because you can't use any inequalities or intervals at all because you don't have a gap of numbers. You only have 5 of them. So inequality notation, we're going to say, is not applicable. You can't write this in inequality notation. You also can't write this in interval notation. The only notation you can use is set notation, and you don't have to say they're real numbers because you're not using a variable. So you're saying that your domain is a set of numbers 2, 3, 5, 7, and 9. And that's all. Same thing for the range. It's a discrete graph, so we cannot write the intervals and we cannot write the inequalities. They don't exist. All I can say is that my range is the set of numbers 1, 3, 4, 5, 6. All right, then we skip to number 11. Number 11, we have Joe has a summer job that pays $7 an hour, and he works between 15 and 35 hours every week. His weekly salary can be modeled by the equation S equals 7H, where S is his weekly salary and H is the number of hours he works in a week. Describe the domain and range for the situation. Well, if we're going to talk about domain, the things that you should know about domain are, it's the x values, but I don't have any x's in this situation, so you need to remember that it's also the input values. And if I'm looking at this equation, S equals 7H, the input values are H, so H will be my domain. So I'm going to describe the domain as in the number of hours that he will work. It's a continuous range of numbers, so we're going to say he can work between 15 and 35 hours, but he could also work exactly 15 and exactly 35. So this is your domain. The range, you know, is the y values, but I don't have any y values, so you need to think of it also as being the output. Well, S is the output, so that's what we're going to use for our range. So I have S. Now, if the domain is a continuous number or set of numbers, then so is the range. So we have to figure out his salary based on his hours. So in order to figure that out, we're going to say, all right, his salary could be 7 times 15, and that's 105. So the lowest he'll make is $105. The highest he'll make, his salary would be 7 times 35, and that's 245. So my domain is all the hours between 15 and 35. My range is the salary will be between $105 and $245. Then the instructions I gave them into class was you have until tomorrow's class to fill in every other blank. So I need you to finish this paper, and then tomorrow I'll give you access to check it.